Hi folks, we're going to take a look at number 16 on page 346. So they give us these two vectors D and E, and they give us their magnitudes and the angle between them, and they want us to find the magnitude of the sum and the magnitude of the difference. Okay, so first thing to remember is that when they give us the angle between two vectors, that implies the vectors being placed tail to tail. Okay, so I'll place the bigger vector here, so we'll call that vector E, which has a magnitude of 5. And then we've got our magnitude D here, which has a magnitude of 3. Okay, and the angle between them is this angle with them placed tail to tail. Okay, so now if we want to determine the sum, in order to do that, I'm going to move this vector over. Okay, and here we have our old parallelogram representation, and this is going to represent the sum. Okay, and then the difference, D minus E, so from the second to the first, okay, this here is going to represent the difference. So this is D minus E, and this is going to be D plus E, or E plus D, doesn't matter, okay, because they're commutative. So either way, same thing. Okay. Now I'm actually going to start with D minus E. I might as well do that because I've already got this triangle with the angle inside of it, and so we'll just use cosine law. So I'll actually start with part B, and here we've got that the magnitude of D minus E, okay, and I'll just apply cosine law, so it's just going to be the square root. So here it's going to be 3 squared plus 5 squared minus 2 times 3 times 5 times cosine of the opposite angle, which is 30 degrees. Okay, so let's calculate that quickly here. So square root of 9 plus 25 minus 2 times 3 times 5 times cos 30. Okay, and we end up with 2.83. Okay, as an approximation. Now, in order to determine the magnitude of the sum, okay, so now let's look at this vector here in green. I'm now going to use this triangle. Okay, still has a magnitude of 5. This still is just the vector D, so magnitude of 3. Except now I'm going to need to use this angle inside the triangle. And this is where we have to remember that there's a relationship between these two angles because of the parallel vectors. They're just supplementary to each other. So this is just 180 minus 30, so angle of 150. Okay, so when I'm trying to find the sum, or the magnitude of the sum, it's the exact same procedure. Okay, the only difference is I'm using that other angle. Okay, the one that's inside my triangle. So this is still 3 plus 3 squared plus 5 squared minus 2 times 3 times 5. Instead here, I'm just going to have cos 150. Okay, and in fact, I think on my calculator, I can save myself some time and go back up there. So I don't know that I'd suggest this on a test. You don't want to make any silly mistakes, but here, just replace the 30 by 150, and here we get 7.74. Okay, and there's our answer. So again, I can't stress this enough, the usefulness of this idea of the parallelogram representing the sum and the difference of two vectors when they're placed tail to tail. Okay, and again, please remember that the angle between two vectors, when that's given, the assumption is that these vectors are placed tail to tail. Okay, that's it for this one.